Hi everyone, welcome to Impact Academy. I'm Yashasvi Chintada. Today let us look at geography, interior of the Earth. Last time we have completed till 10 questions. Let us continue from the 11th question. So which of the following is an example of the most explosive type of volcano? So let us look at volcanism. So volcanism includes movement of molten rock, magma onto or towards the Earth's surface. So you have magma, which is the molten rock stored under the Earth's surface, and it is coming out. So magma, when it is inside Earth, when it comes out, it is becoming lava. Lava is the molten rock that has reached the Earth's surface through volcanic veins. So why are they erupting? Volcanoes are just a natural way through which Earth and other planets cool off by releasing internal heat. So when there is too much heat inside, just like a pressure cooker, volcano erupts and the heat comes out. When it is inside, it is magma. When it is outside, it is lava. So some of the factors that lead to volcanism are plate tectonics, ocean floor spreading, weak Earth surface. So all these are important. Plate movement over a hotspot, decrease in external pressure also can trigger a volcano. So active, dormant, extinct when it erupts frequently. Example is Mount Saint Helens in USA. Dormant is Fujiyama in Japan. See, all these are very important examples and all these things you have to remember. Eruption is not regular, long interval. Then it is dormant. Extinct is no more. Okay, it is not recorded in the historic times. Example, Kilimanjaro in Eastern Africa. In India, the only active volcano is Barren Island. Okay, Barren Island in Andaman and Nicobar is the only active volcano in India. So, basaltic eruption, okay, basic lava, acidic lava, andesitic. Okay, basaltic will have metallic mineral rich, silica rich, andesitic, and basaltic eruption is less viscous. This is highly viscous. Okay, slower solidification solidifies quickly, andesitic eruption. This is quiet eruption. This is explosive, andesitic. Lava flows far and wide. Okay, in this case, less flow of lava because it solidifies quickly and highly viscous, low fluidity. So all these things we have seen. So this is a volcano, and this is these are fissures. This is the flow of lava outside. This is the central vent. Okay, this is called crater. The bowl-shaped depression around the mouth of the volcano is a crater. Ash and cinders, tiny airborne pieces of rock and lava. Bomb, a lump of lava thrown out of a volcano while still molten. Okay, that is a bomb. Eruptive volcanism types based on typical pattern or mode of eruptions. Hawaiian eruption. Okay, you can say outpouring of liquid basalt lava from craters, lava lakes, or fissures. Strombolian. Strombolian is distinct bursts of fluid lava, usually basalt or andesite. There are two types from the mouth of the magma-filled summit. So two types, Hawaiian and Strombolian. Try to remember. And there is Icelandic. Okay, Icelandic is by effusion of molten basaltic lava that flows from long parallel fissures. So not like a typical volcano, like parallel. If it flows, it is Icelandic, and there are other types. Okay, Plinian eruption. Plinian eruption, you can see like this, largest and most violent of all types. So this is important, right? They might ask which is the largest and most violent type of volcanic eruption. We have to identify it is Plinian eruption. Okay, read all these things. It is very important. They are extremely destructive. Mount Saint Helens. It's an example of an active volcano in USA. We have seen, right? Next, and there is what you say Pelion or New Yard. Example, Mayon volcano in Philippines. Pelion, large quantity of gas, dust, ash, etc. fall back from and it forms tongue-like glowing avalanches. This one. And there is also Vulcanian eruption. It's a short, violent, relatively small explosion of viscous magma, usually andesite. So we have seen one is basaltic and one is andesite. They are also powerful explosions. All those things. These volcanoes dormant for decades or for centuries after each eruption cycle. So once a cycle happens, it is dormant for lot of time. So classification of different types of volcanoes. Okay, on the basis of external landforms. Conical vent, narrow vent through which magma comes out. So this is a conical vent, common in andesitic volcanism, stratovolcano. Okay, because there is a explosion and lot of dust. Then fissure vent, through a single fissure, it is coming out. Not much explosive activity. It is common in basaltic volcanism, shield type of volcanoes. Shield volcanoes, you can see this, found at plate margins, mostly made up of basalt. They are not very steep. Okay, less explosive. Example, Mauna Loa in Hawaii, very important. It's a shield volcano. So composite volcano, again plate margins, eruption of cooler and more viscous lava, andesitic lava, violent eruptions, Mount Saint Helens, Mount Rainier, Mount Stromboli in Italy, okay, Mount Vesuvius, Mount Etna, all these are in Italy, I believe. Mount Fuji is in Japan. Mount Stromboli is also called as lighthouse of the Mediterranean. So fine. So that is composite volcanoes. So cinder cone is steep, circular or oval shaped hill structure made up of pyroclastic fragments. It is built around a volcanic vent. So this one, you see, it's a volcanic vent. There is a, due to regular eruption, cinder cone is what you say formed. And crater is, instead of the small opening, you have a small vent opening, you have a large crater. Okay, that is called crater. Inverted cone shaped vent through which magma comes out. It looks like a bowl shaped depression if the volcano turns inactive. Okay, caldera. Caldera is the crater turns into a lake after the seas of magma eruption. So India we have Maharashtra Lonar Lake, which is a caldera. Caldera is basically a crater filled with water. Mount Krakatoa in Indonesia. That is also caldera. Fissure type, okay, mid ocean ridge and so in the ocean ridges under the sea and lava domes, mound shaped protrusions, viscous magma piles around the vent, all that pile. So this is basically so we have seen about volcanoes. Fine. So now let us see what is the question. Which of the following is an example of the most explosive type of volcano? So we have seen caldera volcanoes are very explosive, right? Cinder cones are formed after it became dormant for some time. Flood basalt volcanoes, okay. Shield volcanoes. We have seen shield volcanoes also, right? So shield volcanoes are less explosive. Found at plate margins, mostly basalt. Okay, basalt is less explosive, andesite is more explosive. What is the other one? Caldera. So caldera, where is caldera? See, the crater turns into a lake after the seas of magma eruption. It is known as the caldera. So after the magma eruption has taken place, it is becoming a caldera. So you can see the area is also very high. So among these options, caldera volcanoes are most explosive type. See, because they are most explosive only, such a large crater is formed. Okay, remember that. So which is the most abundant element in the Earth's crust? So we have seen multiple times. If you look at the Earth's crust, right? Where is Earth's crust? So Earth's crust, when we're talking about elements, most abundant is oxygen in the Earth's crust. If you're looking at total Earth, then it is iron, followed by oxygen. Okay, iron, oxygen, silicon, magnesium. Iron is the highest 45%. If you're talking about the oxides, then it is silica, 59%, followed by alumina. But in general, if you are looking at Earth's crust alone, then it is oxygen, followed by silicon, and then aluminium. Only then comes iron. So aluminium in the crust is more. We have also seen Sial Sima, right? So which is the most abundant in Earth's crust is oxygen. So let us look at this. So, so try to observe this. Inner core, okay, outer core, lower mantle, upper mantle, and crust. So we are looking at around the 5 to 100 kilometers. 5 to 100 kilometers is the combination of upper crust and uppermost mantle, which is nothing but lithosphere. And we've already seen asthenosphere is what do you say below this. Where, anywhere we've seen. Okay, anyway, we have already seen right. Asthenosphere is below the see lithosphere. Okay, 5 to 100 is lithosphere, and below that you have asthenosphere. And the asthenosphere is upper part is partially molten, lower part is solid. Remember this. And then you have the mantle. Okay, and you have inner solid core and outer molten core. So within the core, innermost is mostly made up of iron, that is solid, and the upper one is mostly made up of iron and nickel, that is little bit molten. And the mantle, lower mantle, upper mantle. Immediately you have asthenosphere. Okay. So obviously inner core, outer core, mantle, and crust. Of course, this is very easy, but try to remember the kilometers, everything. Asthenosphere and uppermost is lithosphere. Lithosphere is a combination of oceanic crust and continental crust, and upper. See what is this? Okay, it's a combination of continental crust, oceanic crust, and uppermost mantle. So combination of all this becomes lithosphere, 5 to 100 kilometers. And uppermost is CR, followed by SEMA. And interior, it is NIF, NIFP, nickel and iron. Fine. So almost 98% of Earth's crust is made up of 8 elements. Which of the following does not figure? So we have seen the elements of the crust: oxygen, silicon, aluminum, iron, calcium, sodium, potassium, magnesium, titanium is there, hydrogen is also there, carbon is there, sulfur, phosphorus. Try to remember all this. See, a question has been asked not just about which is highest, how much percentage also, so which is not there. So remember all these things. So oxygen is there, it is highest, and followed by silicon, right? Second highest is silicon, 28%, oxygen is 47%, and calcium is there. Okay, calcium is also there. It is 3.5%. It is relatively high only. So carbon is not there in the crust. Almost 98% of the Earth's crust is made up of these things: oxygen, silicon, aluminum, iron, calcium, etc. Next, the vibration direction parallel to the wave direction in the vertical plane is P waves. Okay, we have seen yesterday S waves only go through what you say solids. Remember S for solid. S waves travel through solid only. P waves will travel through all solid, liquid, and gases. Okay, the vibrational direction parallel to the wave direction in the vertical plane is present in P waves. Remember that. Surface wave is on the surface, and they are most destructive because they are on the surface. All the buildings will fall because of the surface waves. Okay. So the interior of the earth can be understood by both indirect and direct methods. So what are the direct methods? Volcanoes, because it is coming directly from the earth, and meteorites, deep mining, okay, fracturing, fissuring, all those techniques. Okay, because we are directly going into the earth. Indirect methods is meteorites, okay, through seismic waves, etc. Because meteorites are also coming from outside, but when Earth had formed, it would all these asteroids, meteorites, all these things would have come together to form Earth, right? So whatever is there in the meteorites, we can study that to find out what is there inside the earth also. So that is why it is called an indirect method. Also seismic waves. Those are all indirect methods. So which is not a type of volcano. We have just now seen, right? Caldera is a volcano, crater filled with water. We have seen composite volcanoes. We have seen shield volcano also. But we have which of them is not a type of volcano? So ridge volcano is not a type of volcano. Okay. If you look at the types of volcanoes, see mid ocean ridge volcanoes are there. Okay, but it is not exactly what you can say type compared to the other things. Okay. So relatively, in the given option, you can say which is not a type of volcano. Let us just quickly cross check composite volcano. Okay, see composite volcano is also there. Composite volcanoes, they are also type of volcanoes. So in the given option, relatively, a ridge volcano is not a type of volcano. Okay, because ridge volcanoes are mid oceanic ridge volcanoes. Because ridges will not be there on the surface, right? Ridges will be there only in the mid oceanic. So in the given options, the best option will be ridge volcano. Mid oceanic ridge volcano is also type of volcano. So volcano is one direct source of information about the interior. We've just discussed, right? Because magma is coming from inside, so we will know what is the interior of the earth. So which of the following describes the lithosphere? So if you look at lithosphere, so lithosphere is a combination of continental crust, oceanic crust, and uppermost mantle. Okay, all these three things combine to form the lithosphere, 5 to 100 kilometers. Remember that also. So now let us go back to the question. And crust and upper mantle, fine. Okay, it's not just mantle. Crust should be there, and definitely not the core. Core is deep inside. So crust and the upper mantle. Okay, oceanic crust and continental crust and the upper mantle together form the lithosphere. So which of the following describes the lithosphere? It's a same question, right? No. Again, yeah, same question. Crust and upper mantle. So what is the thickness of the Earth's crust in the Himalayan region? So generally remember what is the thickness of the crust. Okay, it's around 50 to around 50, 60, right? Okay, you can see from that. So remember this. What is the thickness of the Earth's crust in the Himalayan region? It is 70 kilometers. Try to remember that point. So which one of the following is the direct source of the information about the interior of the Earth? So direct source. So direct source is volcanoes, right? Volcano is the direct source. Gravitational force, earthquake waves, earth magnetism, all these are indirect sources. So answer would be two. Don't go with this answer. Answer would be two. Volcanoes. Volcano is the direct source of information. So what is the density of the rocks between the adjoining line of? So which is what is the density of the rocks between the adjoining line of mantle and core? So in general, the density of Earth, okay, we have seen the density of Earth is 5.52. Try to remember that. That is something which we can remember. We have to remember, and also gram per centimeter cube. This one also is 5 gram. So try to remember if you can between mantle and core. That means between mantle and core. So this is the mantle and this is the core. Here is saying the density is almost similar to that of the total density of the Earth. Try to remember. Next, which one of the following is the indirect source of information? So we have seen deep ocean drilling, mining, and volcanoes are direct sources. Meteorites, seismic waves, all those things are indirect sources. So meteorite is a indirect source. Also, meteorites burn in the which region? Mesosphere. Frequently asked question, right? So remember. So innermost layer is core. Very important, very basic. So how much is the core? See, from 2900 to 6300. Remember, that is the core. Okay, 2000, that means almost 3 to 6, so 3000, around 3400 kilometers. Okay, try to remember that. So which element is the most abundant element in Earth's crust? Remember, Earth's crust is oxygen. If you are talking about oxides, then it is silica, not silicon, silica oxide. And if you are talking about total Earth, then it is iron. Okay, only crust means oxygen. Which element is the second most abundant element found in the Earth's crust? Second is silicon. So first is oxygen. Okay, first is oxygen. Second is silicon. Third is aluminum. Fourth is iron. In this case, iron, oxygen, silicon, magnesium, nickel. Try to remember the order also because the order can be asked. Fine. So which element is the most abundant element found in entire Earth? 20th question. Which element is the most abundant element found in entire Earth? Entire Earth is iron. Okay, we have seen right. Entire Earth means iron, 45%, oxygen, silicon, magnesium. Fine. So which is the second most abundant in entire Earth is oxygen. Okay, entire crust first is oxygen. Entire Earth also oxygen is second most abundant. So in the Earth there is so much oxygen. Not only in the air, there is a oxygen in the crust and oxygen in the total Earth. Okay, remember that. So which of the following statements best describes the nature of the core mantle boundary? So the core mantle boundary is rough with a topography of about 5 kilometers. So he's talking about this. Okay, core mantle. So this boundary, which is the Gutenberg discontinuity. So this question is also frequently asked. Okay, so what is the discontinuity between the oceanic crust and the between the upper crust and the lower crust? That is Conrad discontinuity between the crust and the mantle. Okay, crust and the upper mantle is Mohorovic discontinuity between the upper mantle and lower mantle. Repetti, lower mantle and outer core Gutenberg. Okay, and outer core and inner core Lyman discontinuity. You have to remember it in that order. There is no other option, and it is frequently asked. Okay, I remember the what is the first letters. Okay, CMR GL, CMR GL. Once you remember that, you can easily apply it. Okay, L means obviously between outer core inner core. G means lower mantle and outer core. So that is called core mantle boundary. Gutenberg discontinuity. The core mantle boundary is rough with a topography of about 5 kilometers. Try to remember that. Okay, so we will continue the next place.